Alright folks, today we're working on 6.4c, which is determining if two functions are inverse. So you should have already done 6.4b, which is finding inverse functions. So remember, functions that are inverse are functions that undo one another. So we can say if f of x and g of x are inverse, which is we have one function and another function, if they are inverse, then f of g of x is equal to x, and / or g of f of x should equal x, which says that if you find f of g of x, if you test this and it equals x, so if you do this and it's true, which means that when you do this you get just x as your result, then f of x and g of x are inverse, which is what we want. So we can use this fact to test whether things are inverse or not. So before we get going too much further, I'm going to pause for a moment to let you copy down some things. So example 1, f of x equals x plus 1 and g of x equals x minus 1. We're going to determine if they're inverse. Example 2, f of x equals 2x plus 3 and g of x equals x minus 3 over 2. We're going to determine if they're inverse. And last part 3, f of x equals x squared plus 2 and g of x equals the square root of x minus 2. And we're going to figure out if they are inverse or not. Okay, so now we have all three notes of what we're doing. We're doing the exact same thing every single time. Let's figure out if f of x equals x plus 1 and g of x equals x minus 1 are inverse. Yes, we can plug a number in. That's totally acceptable. So 10 plus 1 is 11. 11 minus 1 is 10. It works. Our inputs are output. Our outputs are input. It works. But that's not really an algebraic proof. So we're going to use algebra. We're going to use the fact that if this works, then they are inverse. This is our converse, so if it says it's our original, then we can flip it around, we get it backwards this way. So we're going to test f of g of x. So we're going to find f of g of x, which is really f of g of x, which says that I'm going to put g of x into f of x. I'm going to find f of x minus 1. So anywhere I see an x, I'm going to write x minus 1. So over here, I've got f of x minus 1 is going to be equal to, well, originally we had x plus 1. We're replacing x, so there's the x plus 1. We're replacing x with x minus 1. So I'm just replacing whatever g was, I'm putting it in the x spot for my f function. I'm substituting it in. So when we simplify, we're going to x minus 1 plus 1. We know that negative 1 plus 1 is going to cancel, so we're left with just x. So because f of g of x gives us just x when we simplify it, therefore, which is what the three dots say, we can say that f of x and g of x are inverse. Woohoo! It worked! Okay, example 2. F of x equals 2x plus 3 and g of x equals x minus 3 over 2. We're doing the same thing. We're determining if they're inverse or not. So I'm going to find f of g of x, which says I'm going to substitute f of g of x, write it in a form which I'm comfortable with, which says I'm subplugging in f of x minus 3 all over 2. Alright, so that's really equal to, so f is this, so 2 and then the plus 3. I'm leaving a space for my x, and I'm writing in g, so x minus 3 all over 2. Okay, 2 divided by 2 is going to cancel, so we're left with x minus 3 plus 3, which does cancel, so we're left with just plain old x, which is what we want. Therefore, f of x and g of x are inverse. Woohoo! Okay, last one. And if, by the way, if you get anything other than x, so if you're left with like 2x, you're left with x plus 1, or you're left with whatever else, it's not inverse. You have to have just x. Okay, so example 3, we've got x squared plus 2 and square root of x minus 2 is our two different functions. So let's find f of g of x, which is f of g of x, which is f of square root of x minus 2 is what g of x is equal to. So leave space for the x, got a squared plus 2, we're going to write in exactly what g is, which is the square root of x minus 2. So the square root of something squared, well, just like in our last unit, the square and the square root are going to cancel out. We're left with x minus 2 plus 2, which does cancel. How fortunate for us, we get plain old x, which says therefore f of x and g of x are inverse. Woohoo! Okay, and again, if you get anything but x, if you simplify it and you get anything but just x, then they're not inverse. So if you don't, first thing that I would check is your algebra when you're simplifying it. Make sure you plugged it in right. If you've got questions, come and ask somebody else to check your work. Because not all things are inverse. I mean, yeah, I kind of rigged it up this time to make it inverse. All right, so get a practice sheet. We're working on the same one from last time. I want you to go back, and now that you know how to verify that they're inverses, which is what this process is called, which is verifying inverses, go back and verify that the inverses you found yesterday work. If they don't, that says that you're going to need to find the inverse again like you were supposed to the first time. So maybe that you came up with something that said plus 3 here instead. You made a sign error somewhere. So we're going to check to see if that same worksheet from yesterday, if they are inverses.